Alright, welcome to the first day of AP Review. We finally made it, guys. Today, we're working on limits. So I'm going to go over the first, I think it's like 8 or 9 or 10 problems on this worksheet, just to remind you of how we do some of these limits. And then we're going to look at them more, or we're going to let you all work on them yourselves. Alright, so let's start with the plug it in. This is pretty straightforward. If we want to find a limit, the first step is to try and just plug in our number into our function. So we have the limit. Well, we won't write the limit again. So we'll say this is equal to the square root of 4 plus 2, which is equal to the square root of 6. And as long as we don't get any undefined or anything like that, then we're fine. We can move on. The next option is to factor. So we can say this factors into t plus 3 and t minus 3. So we're left with the limit as t approaches 3 for t plus 3 times t minus 3 over t minus 3. Those t minus 3's will cancel, and then we can just plug in 3. So 3 plus 3 gives us 6. Alright? Moving on to least common denominator. This is going to be the one that I probably don't have the room for, but we try and get a least common denominator here, which means if this denominator is x plus 1, we're going to make this x plus 1 over x plus 1. So we say the limit as x approaches 0 of 1 minus x plus 1 over x plus 1 all over x. Now this x gets moved up here, and we can simplify some things. So 1 minus 1 just gives us 0, and then a negative x over, oops, got my limit. Limit as x approaches 0. So 1 minus 1 gives 0, negative x over x times x plus 1. These x's will now cancel, and we're left with negative 1 over x plus 1, which we can now plug in 0. So negative 1 over 0 plus 1, which gives us just negative 1. Alright, we can also expand. This one's also going to require me to have a lot of room as well. Let's see. What can I do? Okay, I'll just rewrite it. Now, I think I might have messed up when I was editing this. Your worksheet might not have this. I might have fixed it by then. But this should be a delta x on the bottom here. So what I'm going to do, I'm going to go to the white screen and then we can work it there. So we have the limit as delta x approaches 0 of x plus delta x cubed minus x cubed over delta x. Can't just plug in 0 here, so we're going to expand it. This is going to be ugly. So we end up with I'll do this in parts because my brain's not working right now. X plus delta x times x squared plus 2x delta x plus delta x, oops, squared minus x cubed. So over, we'll do this with delta x, limit as, as delta x approaches 0 of x cubed plus 2x squared delta x plus delta x squared x plus delta x squared plus 2x delta x squared plus delta x cubed minus x cubed all over delta x. So we can combine some like terms, so x cubed and x cubed cancel. 2x squared delta x plus x squared delta x gives us 3x squared delta x. Delta x squared x plus 2x delta x squared gives us 3x delta x squared, and then plus delta x cubed all over delta x, limit as delta x approaches 0. Almost done. Now we can cancel everything, and we get 3x squared plus 3x delta x plus delta x squared. And now we're to the point where we can actually plug something in. Now we can plug in 0. When we plug in 0, this goes away, and we're just left with 3x squared. There's our answer. If you noticed, this was a very special limit. If you can remember what it is, try to. But I'll go ahead and say it, because there's no point in asking, because y'all can't respond. That is the definition of derivative. Make sure you remember that. Okay. Next, we're working with the conjugate. This one I'll also do on the white screen. So we're looking at square root of x plus 4 minus 2 over x. Alrighty. Now, what you do notice is if we plug in 0, we should get 0 over 0. So if you wanted to, you could do L'Hopital's rule here, and you'd be okay. But we're trying to show all of our methods, so we're going to show multiplying by the conjugate. So I'm going to start by multiplying by the conjugate here. Square root of x plus 4 plus 2 over square root of x plus 4 plus 2. Multiply out that numerator, so we get x plus 4 minus 4 over x times root x plus 4 plus 2. That x plus 4 minus 4 is just going to leave us with x on the top. So x approaches 0 of x over x times the square root of x plus 4 plus 2. Those x's are going to cancel. And now we can actually plug in 0. Plug in 0, we get square root of 4 plus 2, which is 2 plus 2, which is 4, and a 1 on top. So this gives us 1/4. Okay. Moving on to a combo problem. This is one where we might have to do a few different things. If you look at this one before I say it, go ahead and try and figure out which two methods we're going to have to use. Okay. Let's see if you got it right. So, this one, there we go. Okay, so for this one, you have to use the methods of common denominator and we're going to have to use the conjugate. Now, once again, because we get 0 over 0, if you wanted to, you could do L'Hopital's rule. And once you get to the problems that you're working on at home, I'm not going to be over your shoulder telling you this is the method you have to use. Whichever method works best with you, that's fine. I'm just trying to make sure you have all of the methods at your disposal. So we have limit as s approaches 0. First we'll do the common denominator, so 1 minus root 1 plus s over s times root 1 plus s. Then we'll multiply by the conjugate. Okay, so we get the limit as s approaches 0 of 1 minus 1 plus s over s times root 1 plus s times 1 plus root 1 plus s. That's our whole denominator. Now, notice I'm not multiplying it out, because if we did this right, this s should cancel and we can just plug in 0 at the end. Alright, so we'll simplify that numerator and we get the limit as s approaches 0. 1 minus 1 gives us 0, and then a negative s over s times square root of 1 plus s times 1 plus square root of 1 plus s. Oh, look at that, I was right, those s's cancel. We're left with a negative 1 on top. We'll get rid of that whole thing. Left with a negative 1 on top. Plug in 0, we get 1 times 1 plus 1, which gives us negative 1 over 2. Okay, and there's our answer to that one. Now we get to L'Hopital's rule. Anytime we get 0 over 0, we want to do L'Hopital's rule, or infinity over infinity, or any one of our indeterminate forms. Now this one does be 0 over 0, so let's look at how we would work this one. We have the limit as x approaches e of natural log of x minus 1 over x minus e. Make sure that's right. Yep, that's right. Okay, so if we just plug in e, we see that the numerator goes to 0, so the limit as x approaches e of natural log of x minus 1 equals 0, and the limit as x approaches e of x minus e equals 0. So we have indeterminate. L'Hopital's rule, limit as x approaches e. Now when we do L'Hopital's rule, we do the derivative of the top over the derivative of the bottom. Alright, so what's the derivative of the top? Well, derivative of natural log of x is 1 over x. Derivative of 1 is 0. Alright, over derivative of the bottom. Derivative of x is 1. Derivative of e is 0, because e is a constant. So this gives us the limit as x approaches e for 1 over x. And then we can just plug in e and get 1 over e. Pretty easy. Now, a lot of y'all are probably going to ask me, do I have to write this every time? I would recommend it. Once again, we're having the changes in the AP exam being so up in the air. We don't know where they're going to try and look to nitpick. Like they used to have a full test that they could do with multiple parts and free response and multiple choice. But this year it's only going to be 45 minutes. It's going to be short, so they might be nitpicking a little bit more. So this is a very for sure way to write L'Hopital's rule that makes sure you get all your points. You don't say 0 over 0. You say the numerator is equal to 0 and the denominator is equal to 0. It's indeterminate. L'Hopital's rule. Really easy. Not a whole lot of extra writing, okay? All right. Now we move to limits at infinity. These we have 3 ways to do, and we're going to look at all 3 of them. Give me a second to make sure this gets written properly. All right, let me make sure I write all of this. So we have limit as x approaches infinity of 4x cubed minus 3x minus 4 over 6 minus x plus 2x squared minus 6x cubed. Alright, 3 ways to do this. First one is the easy one, L'Hopital's. Okay, we can do this with L'Hopital's. Alright, so let's go ahead and do it just like we did it last time. We have the limit as x approaches infinity of, well, we know the limit as, well, let's do it here. Limit as x approaches infinity of 4x cubed minus 3x minus 4 equals infinity, which is equal to the limit as x approaches infinity of 6 minus x plus 2x squared plus 6x cubed. So we'll do L'Hopital's rule, LH, and we have limit as x approaches infinity for 12x squared minus 3 over negative 1 plus 4x minus 18x squared. Gonna have to do it again. I would say write this again. I'm running out of space, so I'm not gonna write it again, but I would recommend you do. Limit as x approaches infinity of 24x over 4 minus 36x. Getting even closer, L'Hopital's again. Limit as x approaches infinity of 24 over negative 36. Well, that's just going to be whatever 24 over negative 36 simplifies down to. They're both divisible by 6, so we end up with, well, probably even more divisible by, they're more divisible by 12. So we had negative 2 over 3. There's our final answer. That's with L'Hopital's rule. Now, L'Hopital's rule is very straightforward, but it's not always the easiest. Okay, let's try our next method. Next method is what I would consider the easiest, but not always the most straightforward. Next method is horizontal asymptote. We've done these a few times with what we were doing with series. So we look at the biggest power on top and the biggest power on bottom. Our biggest power on top is cubed, biggest power on bottom is cubed. So when we have a common power, we can divide the leading coefficients. So 4 divided by negative 6, that gives us negative 2 over, sorry. Let me just not jump things, because I'm going to make mistakes that way. Negative 4 over 6 by horizontal asymptote. Okay, which gives us negative 2 over 3. Pretty straightforward, or pretty easy, but not always going to be straightforward depending on which the power is and all that. Okay, the last method is by dividing by the biggest power of x. Okay, so our biggest power of x is still x cubed. So what we're going to do is we're going to divide every single term by x cubed. Well, that gives us 4 minus, well, 3x over x cubed is 3 over x squared. Oops. Minus 4 over x cubed is just 4 over x cubed. 6 over x cubed is 6 over x cubed. X over x cubed is 1 over x squared. 2x squared over x cubed is 2 over x. And then 6x cubed over 6 over x cubed is just 6. And then look at what happens. As x goes to infinity, this goes to 0, 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 and we're just left with 4 over negative 6, which is negative 2 over 3. All of them giving us the exact same thing. Okay? We have limits at infinity. All right? We just did that. So the last thing we have is one-sided limits. Okay? Both of these are one-sided limits. We're going to look at both of them. And then I'll let y'all just work on the practice. Okay, so we have g of x is equal to square root of x minus 1. X is less than or equal to 1. X plus 1 if x is greater than 1. Alright, we're looking at it from the right and then from the left. So let's start with from the right. Limit as x approaches 1 from the right of g of x. Well, if we look at this, which side of these comes from the right of x? Well, the right is numbers that are more positive than x. Well, this, or more positive than 1, this is the side that deals with numbers that are bigger than 1. So we're really looking at the limit as x approaches 1 from the right of x plus 1. Now, if this is a discontinuous function, then the x approaching from the right is important. But this isn't discontinuous. This is a completely fine function that is continuous at every point. So we just got to see what is this function whenever we plug in 1. Well, when we plug in 1, that equals 2. Now we're going to look at it from the left. Okay, so approaching from the left, we end up with this function is the one we're working with right here. So we have the limit as x approaches 1 from the left of the square root of x minus 1. Now this one is not a continuous function, but is it continuous on the left side of x, or of our x that we're plugging in? And that is true. It is continuous up to that point. So we can go ahead and plug in 1, and we can say, okay, this is just the square root of 1 minus 1, which is 0. Now, the question that is not asked on there is that if the limit from the right is 2 and the limit from the left is 0, what is the actual limit as x approaches 1 of g of x? Should be a quick pause while you answer. Yeah, you should have gotten does not exist. When the limit from the left does not equal the limit from the right, it does not exist. Okay? So that is all the practice problems we're going to look at. The rest of this worksheet is for homework. It should be attached to the task for the video. Y'all have a great day.